welcome back. Let's pick up where we left off last time. So this is part 2 of our georeferencing topic. Last time we discussed how to orthorectify or georef a scanned map image using printed coordinates. This time I'll be showing you how to georef or orthorectify a scanned image using a satellite image as our control map. So this is what we call image to image orthorectification. First thing that we need to do is we need to install Quick Map Services plugin in our QGIS. In place of Quick Map Services, if you have XYZ tile in your browser where it allows you to view satellite images, that's okay, that's totally fine. But Quick Map Services is easier to use, and it offers you a lot of satellite servers when it comes to the sources of the images. So first thing that you need to do, you need to go to plugins in your QGIS menu toolbar and click manage and install plugins. So here you have the plugins dialog window. Just type in the search bar Quick Map Services. Quick Map Services. Then select Quick Map Services and click install plugin. Important that you have internet connection while installing plugins, because you will be basically downloading plugins from QGIS repository. So you need to have an internet connection. So here we have the Quick Map Services plugin. So now we can close this dialog window. So next thing that we need to do, of course, we need to open our Quick Map plugin. Just go to menu toolbar in your QGIS window, then click web and click Quick Map Services. So if this is your first time using a Quick Map Services plugin tool, you might notice that your items here are few compared to what I have here installed. So what you can do is you can go to settings, and then in the among these tabs here, click more services and click get contributed tab for you to be able to download the other satellite servers or imagery in your Quick Map Services plugin tool. Then click OK once you've done downloading the sources, and then click save. Basically, you are connecting to the additional satellite servers. So again, let's open the Quick Map Services and let's open Google Satellite as our main map or our control map, wherein we will be collecting or getting our coordinates. So click Google Satellite. So here we have the Google Satellite image. So next thing that you need to do is, of course, you need to open your raster by way of opening the georeferencer window. So you need to load your raster data or your scanned map image without printed coordinates. So go to raster in the menu toolbar and click georeferencer. So here you notice that I have my georeferencer docked in my main QGIS window. So the usual the default function of the georeferencer window, usually it is a separate window. So what you want to do, if you have a separate georeferencer window, you can go to settings of your georeferencer window, click configure georeferencer, and then click show georeferencer window docked, so that it will be docked in the main QGIS window. So click this one and then click OK, and your georeferencer window will be docked, your main QGIS window. So next, let's load the raster data or the scanned map. So again, click open raster and locate your saved scanned map. So I'll be using this one. This is a map, a portion of Davao City. Okay, so basically this is just part and parcel of our first scanned map that we've used in the part 1. So what I did is I cropped the I just cropped a small portion for this particular exercise. So as you notice, this particular map doesn't have any coordinates printed on its layout. Okay, so now that we have loaded our scanned map without coordinates, so take note that this is just a JPEG file. It's not yet GeoRef. Okay, so now that we have downloaded our or opened our scanned map, so I'll be zooming in using the zoom tool in the toolbar, QGIS. I'll be zooming in, of course, to Philippines, and lastly to Davao City, because that is the location of my target map in this particular area here. So here the satellite image is our control map, wherein this will be the source of our coordinates, and this is our target map, our scanned map image. So again, I'll be zooming into the portion of this scanned map on our target window. Okay. Principle in georeferencing, especially if you don't have any known coordinates. Actually, what you can do, there are a lot of ways you can do. You can record the coordinates on the ground. So you need to identify specific ground control points in your map, and then go to the location on the ground and then record the coordinates using a GPS receiver or cell phone or any device that captures that can capture coordinates accurately, of course. But since it might be impractical to some extent, so what you can do is you can use this technique. So you have a target map, and you have a target map, which is this one, and you have a control map. So first thing, let's identify some notable features in our scanned map that we can easily identify, we can easily pick in our control map. So here we have this particular bridge here. Okay. So again, first we need to add point. So for us to add point, just click this icon, add point, and then you need to make sure that you are recording, especially if you are using road intersections as your point of reference. You need to make sure that you are recording the center line of the road intersections or your bridges. So in this case, I'll be recording this part here, which is the center line of this particular road segment, or the approach of the bridge. This one. So here, since we don't have any printed coordinates for us to input in these fields, what we want to do is click this option here, from map canvas, because we will be getting our coordinates from our control map. Okay, so click from map canvas and then point to the exact location on your control map. So for example, this one, then click and then click OK. So now you have already have your first point. But before you are going to collect or record your coordinates, the different GCPs, make sure, very important step is that you have to make sure that you have to change this change the coordinate reference system here in the on the fly tab. So the default coordinate reference system shown in the on the fly is WGS 84. But since I'll be using Luzon 1911 as my geographic coordinate reference system, so I need to select Luzon 1911. This is very important. Otherwise, you'll have errors when you georef your map. So basically, you need to make sure that you have the same coordinate reference system in your on-the-fly CRS here and in your transformation parameters. So since I'll be using this one, I'll choose Luzon 1911. So click apply and OK. So now I have Luzon 1911 as my on-the-fly coordinate reference system. So again, let's add point. From map canvas, I have to make sure if this is the correct reach. Okay. So again, middle of these two lanes. Okay. So now that we have our first point, let's add more points. So the goal here is for us to be able to align our road networks to that of our control map. So for our next point, I'll have this particular intersection here. I'll have this as my second point. So let's zoom out and I locate where it is in our control map. So this one. So this is the same intersection here. Again, click add point, and then click from map canvas, then pinpoint to the center line of the intersection. Click OK. So again, let's add more points. I'll have this intersection here. Which is this one. Okay. Again, click add point from map canvas and then pinpoint to the exact intersection. Okay. Now let's identify more points for us to be able to align our road networks. In some cases, in place of road networks, you can use other notable features on the ground like monuments, natural features like rivers and lakes. But since we are working with an urban area, so it's easier to identify road networks as our point of reference. Okay, so I'll have my another GCP here. So let's zoom in. When you zoom in, you can use the scroll button when you're using your mouse. Okay, click add point, and then approximately I want to target the center island here, so I'll just estimate. From map canvas, and then okay. let's go to our next point. So I want to record this particular intersection here, this Y intersection, which is this one. Then click add point from map canvas, and then okay. You observe that I'm adding a lot of points because I want to make sure that my road networks are properly aligned. So I'll have this point here, intersection here, and here. Let's do this one first. Zoom in middle line. Make sure that if you are recording intersections, make sure that you are recording at approximately at the middle line of those of the road networks. Middle here and middle of this road here. Okay. Again, click from map canvas and zoom into the area. So I have this here. Okay. Zoom out. Next is this intersection here, which is this one. Again, click add point, zoom in. Click from map canvas and again zoom in for you to be able to get the exact center line of the intersection. Okay. So we need to add more. Let's add one here, here, and here. Zoom out. Okay. Another one here. The greater the number of your GCP, the more accurate your map or your georeference map will be. Especially if you are doing image-to-image orthorectification for the purpose of detecting land use changes or maybe land cover changes, you need to add, or you need to make sure that you are aiming more control points. So let's add one here. Next, zoom out. Next, let's have this one here, which is this one intersection here is this one. Again, zoom in. Okay, click add point. Click from map canvas. Okay. Let's add one here. Click from map canvas. If I'm not mistaken, this one here. Again, map canvas. Okay. So also let's pin these features here, this one and this one, so that our wharf or port is aligned with our control map. Middle, click from map canvas, then approximately get the center line. Okay, and this one, just this one. So again, click add point, get the middle, point to the center line. Click from map canvas and then do add again. Wait, I need to zoom in. From map canvas. You can see there is a center line here, so I'll be pointing. Okay. We're not yet done, so we need to zoom out. Again, our goal is we want to spread out our GCP, our ground control points, for us to be able to stretch our map accordingly. So here you can see we have some notable features here which are also present on our control map, so let's use them. Let's add point. Let's start with this one. So if you're adding point, make sure that you are doing it either clockwise or counterclockwise. Okay, then zoom out. Let's get the other one here from map canvas and then center. Okay, let's zoom out. I want to align this particular crossing here, so I'll be pinning this one also, which is this one. Okay, click add point. Approximately locate the center line from our canvas. Okay. Zoom out. So let's add one here and one here. Which is this one. We need to get the center line of the road networks. Let's use this particular intersection instead. Zoom out to check. Okay, I guess this is the intersection. 1, Again, click a point, then click from up canvas, then zoom into the control map. Okay. This is quite a painstaking task, so it's important that you have to be patient, especially if you want to detect changes in your maps. So let's have this. Let's have this one here and here. So that's okay. Point, click from up canvas. Center line. This one. Okay, this one. Up canvas. Get the center line. Zoom in. Okay, let's have this one. This is this one here is Rojas Boulevard, where we have the Rojas Night Market. So let's paint this intersection here. From up canvas, center. Okay. We're almost done placing our GCP. I want to have this one pinned also, which is this one. So again, it's a point. Map canvas, click. Zoom out. So let's place points here and here. Our canvas, and then this one. Okay. Then another intersection. Again, it doesn't mean that you have to add points whenever there are intersections. It depends on your level of accuracy that you are aiming to get. Since I'm trying to have the coordinate launch aligned, so that's why I'm placing a lot of control points. Okay, let's have this one here, which is this one. Okay, this is the Magallanes Rotonda. Okay, got point. Zoom to the monument. Okay. Then let's have our last point here. Click from our canvas. Okay. So click zoom to layer. So all in all, I have how many points? 25 ground control points. It might look overkill. Again, it depends on your purpose. If you want to digitize the land features, the blocks, you can have fewer ground control points. But if you want to make sure that your road networks when you digitize are properly aligned, you can place control points generously. Okay. So next step that we need to do is you need to set the transformation parameters. So click this icon here, transformation settings, and then since I'm not just doing a simple rotation of the scanned map, basically what I'm doing is I'm stretching the map according to the points that I've recorded. So I'll be using thin plate spline, this one, and I'll try to use Lanzos. And for the target SRS, we need to use Luzon 1911 for our coordinate reference system. Again, Luzon 1911 uses degrees as its unit of measurement. Don't use a projected coordinate reference system which has meters, because that would mess around with your location when you're going to overlay it on the Google Earth. So again, if you don't have this option here, just click this icon and then type in the search bar 4253 or the EPSG of Luzon 1911. EPSG are the unique identifiers of all the coordinate reference system. Luzon 1911. Just click this one under the geographic coordinate systems. Luzon 1911. Then okay. Okay. So output raster. Of course, we need to specify where we are going to save the georeference map. And make sure that you know where you are saving your file. So you need to at least have a file directory for your QGIS files. So again, as a good practice, I'll be indicating the CRS that I'm using. So Luzon 1911, for me to be able to easily identify the CRS of the file. Save. Oops, I'll just replace this one. For the compression, just select none, and you could save the GCP points, or you could discard the GCP points. It depends on just I'll be saving it. Again, you can generate a PDF map of your georeferenced image, and also you can also generate the PDF report where it will show you the RMSE, or the root mean square error of your georeferenced image or orthorectified image. So load, click or check this load in QGIS when done, and click OK. So after we have specified the transformation parameters, then click Start Georeferencing. So depending on your computer, depending on your image, depends on the size of the image, it might take some time to complete the georeferencing process. Okay, so again, now you can see the georeference map overlay in our target map. So I'll be closing this georeferencer window, and let's check the accuracy of our steps in terms of the alignment of our road networks. So again, what you can do for you to do visual accuracy assessment, you can go to the properties of your georeferenced image by clicking right click and then go to properties. Go to properties, and then under these tabs, select transparency and adjust the global opacity according to your preference. So again, so you can do that. Let's hit apply. So that's the result. Alternatively, if you have this the layer styling enabled, you can just go directly here and adjust the global opacity. Okay, so let's try to do some visual assessment. Okay, so we can see that our scanned map, our scanned image, in terms of its road networks, are aligned to that of our control map. So that's how we're going to georef a scanned image, especially if you are doing image-to-image orthorectification. So you need to make sure that you are using a lot of points for you to be able to have a higher degree of accuracy. But for the purposes of just digitizing simple blocks, maybe you can use fewer control points. But this one, I want to make sure that my road networks are aligned, so that's why I used close to 26 ground control points. So what is the practical application for these georeferencing steps? Practical application is if you have old scanned maps wherein you don't have the printed coordinates, or maybe the coordinates are not already faded, or maybe removed from the map. So you can do this one, but just by identifying these similar features in your target map and in your control map. So you will be getting your coordinates from your target map. So in this case, I used the satellite image. And if you have a georeferenced scanned map, you can also use that one. Or if you want to go to the ground, collect the coordinates, which is in most cases is a little bit taxing because you need to go to the ground and you need to spend. You can also collect your coordinates from the ground using a GPS receiver. So this one we can now check the we can now do some measurements. I'll adjust the opacity. I'll bring this up to 100. Now let's say you want to measure the length of this particular road segment, this one. So what you can do, since this is already georeferenced, so you can get the measurement. So, for example, this particular road segment, it is 276 point something meters. Okay. So that's it. That's how you georeference the scanned map without printed coordinates. And next time I'll be showing how to digitize points, line, and polygon from your georeferenced scanned map. So stay tuned.